All right, everybody, welcome to homework 2.14. I just had a very dramatic pen issue, but it now has a new battery and it's working. And so hopefully today's will be better than yesterday's. All right, so let's get started. The function a gives the distance of x from 0 on the number line. So remember that absolute value is by definition the distance from 0 on the number line. So 8 is 8 spaces away from 0 on the number line. 5.6 is 5.6 numbers from the space from 0 on the number line. Pi is pi. 1/2 is 1/2. 1 is 1. 0 is 0. Negative 1/2 is positive 1/2. Negative 1 is 1. Negative 5.6 is positive 5.6. And 8 could either be negative 8 or it could be 8. Let's make it negative 8 just for the sake of this since we have positive 8 up here. All right, and so if we graph these, what you're going to end up with is 1 is 1, 2 is 2, 3 is 3, 4 is 4, and so forth and so on. And then on the negative side, when I go up, down, or back negative 1, I'm going to go up 1, because negative 1 as an x value, then when entered into our absolute value becomes a positive 1. Negative 2 becomes a positive 2. Negative 3 becomes 3, negative 4, 4, and so forth and so on. And so you will have that standard V shape for absolute value. Now it says Andre and Elena are trying to write a rule for this function. Andre writes it as this, and Elena writes it like this. Both of these equations are correct, but how is that the case? Well, for Andre wrote a piecewise function, and as you know, absolute value is a piecewise function. So Andre wrote a piecewise function where when x is greater than or equal to 0, we have a positive slope. That's not how you spell slope. Let's fix that. And when x is less than 0, we have a negative slope, right? So using Andre's piecewise function, right, that tells us that when it's less than 0, we have a negative slope, so negative x is our equation. And then on this side, when we're going up, we have a positive slope, so positive x is our equation. And they intersect at where x and y equals 0 at the origin. And so Andre's is a piecewise function, and then similarly Elena's is using absolute value. So our y values will all be positive. And if you remember from today's lesson, this means that we have a vertex of 0, 0, which we do. All right, the absolute value function can be defined using a piecewise function, as we just saw with our friend Elena up here. Use this notation to find the following values. So when I input 10, I get 10. When I input 0, I get 0. When I input negative 3, right, if I input that there, because negative 3 is less than 0, I would put negative 3, right, because this is part of that equation. And a negative becomes a positive 3. This is going to just be 3.14159, which is your pi. And then to get a 7, x could equal negative 7 or x could equal positive 7. Either one would be accurate, because if I input a negative 7 there in my absolute value notation, I'll get a positive 7. A of x equals negative 5. So this is impossible. It's not going to happen, because whatever I put into here is going to produce a positive number, and we can't have a negative output with our absolute value. Here are 4 equations of absolute value functions in 3 coordinate pairs. Each one represents the vertex of the graph of an absolute value function. Match them, one of them isn't shown. So here, remember, if we have a -9 in the parentheses, we're moving to the right. We know this because if I have 9 comma 0 and I put a 9 in there, 9 minus 9 equals 0. So that works. So this means this matches with number 2. Here, if I have it outside and it is added, that means we're going to go up. If we're going to go up, then I'm going to be looking at 0 comma 9 here. And in this case, we do not have any matches here. Okay, so this B is where we don't have a match. C for r of x equals x plus 9. This plus means that I have to move to the left. So that would be negative 9 comma 0, which is number 1. And then this last one, the minus 9 means I'm going down. And so I would have 0 comma negative 9. And I know that because if I plug in 0, 0 minus 9 gives me negative 9 as an answer. So I know that that works. So that's one way that you can test it to make sure if you can't remember, right, which way you're going to go. So this is equation number 3, or sorry, vertex number 3. All right, function g is defined by this equation, function r is defined by this equation. How is function r related to graph g? Sketch the graphs of the two functions to show the relationship. So let's go ahead and sketch g of x equals the absolute value of x we know is our standard absolute value graph, right? When we have this plus 2 outside of that, that means that anytime I put a value for x in here, it's going to be increased by 2 for an output. So if I put 0 in here, it's going to be 0 comma 2. If I put 1 in here, it's going to be 1 comma 3. 2 is going to be 2 comma 4, right? And so this graph is going to have all of the points move up too. So move up, or translate, if you want to use your big math geometry words, translate up 2 points. All right, here is a graph of a function. Select the equation for the function represented by the graph. So here, my vertex has not moved left and right. It has only moved up and down, which means whatever I'm looking for is going to be outside of the absolute value. And so this is going to be looking here at minus 5. And so that very nicely matches with A. Now, B is wrong because that would move it up. C is wrong because this would move it to the right. And D is wrong because that would move it to the left. The temperature was recorded, so this is a review, several times during the day. Function T gives the temperature in degrees Fahrenheit and hours since midnight. Here is a graph of the function. Pick 2 consecutive. Consecutive means one after the other points, and connect them with a line segment. So I'm going to pick this point right here. Getting real close there, okay, because they're one right after the other, and it'll be relatively easy for me to. So it says find the slope of that line. Remember, the slope of that line is if we draw a triangle, we're looking at the difference in y over the difference of x. So our later y value would be from this point, and that's at approximately, we'll say this is 45 right here. So we'll say that's 47 minus, we'll say this one is probably about 41. And then our x values need to go down here. So this is 5, this would be like 7.5. So here, this would be like 6, and then our later value looks to be about 8. And so we're going to get here 47 minus 41 is 6 over 2, it's just 3. This means the temp increases by 3 degrees per hour on average. Okay, so again, this is coming from this formula. Or if you want to think of it in this way, but it's your later output minus your earlier output over your later input minus your earlier input. Now it says pick 2 non-consecutive points. So I'm going to use the same first point, but I'm going to choose a different second point. So I'm going to go from here to here. These are not consecutive, right? That other one's a little bit later. And so what's nice here is I know my initial starting values are going to be the same. So they're going to be minus 41 and minus 6. But now I need to look at the values here. And so this is approximately 51. And it is on the line, so it is exactly 10. So 51 minus 41 is 10. 10 minus 6 is 4. And so that would give me 2 2/4 or 2.5. So in this situation, the temperature is increasing 2.5 degrees per hour. All right. Our last part, the tennis ball is dropped from initial height of 30 feet. So this means that we need to start at 30 feet. It bounces 5 times, so we should have 5 bounces, with each bounce being about 2/3 of the height of the previous bounce. So I'm going to go ahead and mark other points on this 10 and 20. So after the first bounce, if it's going 2/3 of the original height, then it would be up to 20, right? And then 2/3 of 20, right? If we take 20 times 2/3, we're going to get 40 divided by 3. And you can use a calculator for that if you like, but 40 divided by 3 is going to give us 13. So it's going to be just above the 10 on the third bounce, or second bounce rather, because this is bounce 1, bounce 2. And then, so bounce 1, bounce 2. Then it is going to go up another third of that, or sorry, 2/3 of that. So times 2 divided by 3 will give us 8.88, so just under the 10. And then 5.9, so about 6-ish, right? 3, 4, we're going to do one more bounce. And it's going to be 3.9, so, right, you don't have to be super exact. But this is a sketch of it, and make sure to label the axis. So the axis here, this is feet, and these are bounces. Or in this case, it's a function of time. So we are labeling the bounces, but I should actually say that this is a function of time in most likely seconds. It doesn't actually say, but we're going to say time in seconds. So the domain then would be, our input here is however long it takes to bounce 5 times. But really then x is greater than or equal to 0, right? From the starting point to however long this takes. We don't know how long it took, so it could be any. And then the range, our y value is from 30 feet to the ground level. So y is less than or equal to 30 and greater than or equal to 0. Here are 2 graphs representing functions f and g. So g is this function right here, and f is this function down here. So it says identify at least 2 values where g of x is greater than f of x. So we're looking at the y values of g of x compared with the y values of f of x. In this case, then, g of x is greater than f of x here on this curve right here. And so 2 points that I could identify, an easy one here, is 1, 15. G of x here is greater than f of x here. I could also say, let's pick another. No, we'll just go ahead and use this one, right? 0, that looks like maybe 14 or 13. Or you could choose here. But basically any points on this line where it's above this line shows us where g of x is greater than f of x. All right, that's it for your homework. Your code word for today is Duracell. If you can spell Duracell, you know what that is? Extra credit. So write the word Duracell at the top of your paper if you would like extra credit. If you have any questions, please reach out to me as always. And just to give you a little preview, tomorrow we will be going over something called inverse functions. And so just wrap your head around that. All right, see you tomorrow. Happy homeworking.